Hi everybody, this is the lesson 8 video, and I'm going to give you a heads up right now that this is going to be one of those videos that's going to take you a long time to complete if you do it the way I'm asking you to. Okay, so for this one, I'm going to ask you to do all of the formulas and plug in all the stuff before I do it on here. That way you are getting that practice in. Because by you copying down the numbers that I write down here, it's not going to help you at all. I want to make sure that you could do it on your own first, and then double check your answers with mine, okay? So whenever I say to pause the video and try and do the next problem on your own, or as much as I tell you to do, okay? So first we're going to start with this opening exercise, and it says that a rhombus has diagonals, lengths of 16 inches and 30 inches, and you have to figure out the perimeter. So that's one of those questions that we did a long time ago, and you would draw your picture, and you would have to know that in a rhombus, the diagonals are going to bisect each other at right angles. So that means you're going to get 4 right triangles inside your rhombus. And since you have right triangles where you know 2 of the sides and you're looking for the third side, that means you can use the Pythagorean theorem. So you'd use Pythag to figure out what x is, which is the outside piece. And since we're doing the perimeter, you're going to have to multiply that times 4. So it's going to be 4 times 17, and that's going to give you 68. Okay? So that's about the speed that I'm going to go over these. Okay? I'm going to have all of the work up here, but it's stuff that you guys should be able to do on your own at this point. Okay? So let's start by looking at example 1. For example 1, we have a triangle, and it says side AB has midpoint of D, BC has a midpoint of E, and AC has a midpoint of F. Okay, so you can use your midpoint formula, or you can just look at your graph and find those midpoints. But for good practice, here's the midpoint formula, and you can do the midpoint for each of those. So I'm going to show you what it looks like for our first side. So to find the x value for the midpoint, you plug in x1 and x2 for AB. And then you're going to do the same thing with the y value. So y1 and y2 get plugged in. And that means your point is going to be -2, 3. Okay, that comes from AB. So AB is right here. You have x1 and y1 and x2 and y2. So you're going to do the same thing for BC and for AC. Okay, so pause the video and see if you can plug into these two formulas using BC as x1, x1, y1, and x2, y2, and the same thing for AC. Okay, so BC, you're going to find the midpoint of that, and that's going to be 3, 4, and the midpoint of AC is going to be 0, -2. So on your graph, it should look like this, and that is, they all look like they're the midpoint, so that means you have done it the correct way if they look correct. If you did a midpoint and it ended up over here or way up here, those don't look like the midpoint, so that's your hint that you did something wrong. Okay, so it says that we want to prove that that shape that we made, the quadrilateral ADEF, we want to prove that it's a parallelogram but not a rhombus. So first we're going to prove it's a parallelogram. Okay, so a parallelogram is going to be a quadrilateral where the opposite sides will all be congruent. Okay, there's lots of different ways you can say that or prove that. And there's more than one way to prove something's a parallelogram. You could do all of these. But the one that I'm choosing to do here is this one. And that's because this is a rhombus problem, it's better to use this one, and I'll show you why once we get there. Okay? But what I want you to do to start for this one is to find length of each of the four sides, and you can do that using the distance formula. Okay, so if you need it, the distance formula is this, and you're going to find the distance of AD, EF, DE, and FA. Okay, so pause the video and plug those in. Okay, once you plug those in, you should have this as your setup or something really close to it. If you have some of your numbers moved around a little bit, it's okay, as long as your final answers end up being the same. So when you solve, you'll have something that looks like this. Okay, if everything in here is all mixed up, but these are all the same, then you're fine. Okay, but if you have something different for your final answer, then you definitely did something wrong, and you have to double check if you plugged into this correctly. So the opposite sides here, AD and EF, okay, so that's AD and EF, those are both the square root of 41, so these are congruent. And then our other two are both 6, so those are congruent. So that means that it's a parallelogram because opposite sides are congruent. Okay, but a rhombus is different. Okay, in a rhombus, it's a parallelogram with all four sides the same. So it can't be a rhombus if the adjacent sides are not congruent, because all of the sides need to be congruent. So this is our final statements for this. We know that ADEF is a parallelogram because the opposite sides are congruent, but it's not a rhombus because the adjacent sides are not congruent, right? So like AD and DE, those adjacent sides right next to each other, they need to be congruent. Okay, so if you look at the rhombus rules that we have, we know it's a parallelogram, and in order to make a parallelogram become a rhombus, you need two sides next to each other to be congruent, and that's not true because in one of our cases, we have the square root of 41, and the other case we have 6, and those are not the same, so that means that our shape was not a rhombus. So that is it for that first question. Okay? The reason I chose the distance formula to prove it's a parallelogram is because that helped us solve the rhombus question as well. If you wanted to do one of the other ones, like say you wanted to do this instead, and you found out it was a parallelogram by doing slope, and you said that they were all parallel, that's fine to prove that it's a parallelogram. That totally works. But then to figure out if it's a rhombus, you're going to have to use the distance formula anyway. Okay, so read the entire question and think about which option is going to save you the most work. Okay, that's what I want you to learn from these. It's you're planning ahead and able to make good judgment calls on these. You don't want to waste your time doing 8 different formulas when you can get away with just doing distance. So if we look to example 2, we want to prove that we have a rhombus. So let's look at our rhombus rules. So these are the rules that we did when we did the regular 2-column proofs. And one way that we can say that a 4-sided shape is a rhombus is by proving that all four sides are the same length, which means we would use the distance formula 4 times, which is kind of like what we just did. And the second way that I've got crossed out here, we're not going to use that way because that involves finding the measure of angles, and we don't know how to do that for a graph. So we're not even going to use that one. Another one is this one, which is that if the diagonals are perpendicular bisectors, then it could be a rhombus, or it has to be a rhombus. So you can do that by finding perpendicular lines, which means you'd have to do slope. And then if they're bisectors, that means you can do the distance formula for all of these pieces if you'd like, or you can say that they have the same midpoint. And that would just take a little bit of explaining. But I think this is the way that's probably the easiest, requires the least amount of thinking. You just have to do the distance formula 4 times. The other ways is if you've already proven that it's a parallelogram, you can just do the distance formula for 2 sides right next to each other. And if those are the same, then that means everything will be the same and it's a rhombus. And then the last way is that if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So if you already know that this is a parallelogram, then you just need to do the slope for the 2 diagonals. And if they're negative reciprocals, that means it's a rhombus. So keep these rules close by and we will keep referring to those as well. But again, this is the one that is probably the easiest to do. All right, so for example 2, we're going to prove that it's a rhombus, and I'm going to do the one that I just mentioned by doing the distance formula 4 times. Okay, not only is it easy to just do the same formula over and over again, but it's also one of those formulas that we've been using a whole bunch, so you should be pretty good at it by now. So I'll do the first one with you. We're going to do the distance for this side right here, PL, and when you plug that in, you're going to get that, and you could take everything on the inside of the square root and put that in your calculator if you'd like, and you're going to end up getting 17. Okay, and then you keep the square root around it, so it's the square root of 17. Now, you're going to have to show the work for the rest of these. You can't just assume that they're all going to be the same. So you have to show the work in order to get full credit for your homework assignment. So do all 3 of these, the rest of them. Make sure that you get the answer that you're expecting, and then unpause the video to see my work. Okay, so there's the rest, and as you can see, you should get the same number for all 4 sides. Because we're proving that it's a rhombus, that means it is a rhombus, and we're just showing why it actually is. And to finish off the proof, we have to write a sentence explaining why we use the distance formula and what it's telling us. So we know that all 4 sides of this quadrilateral are congruent because they're all the square root of 17. So that means it has to be a rhombus because a rhombus has 4 equal sides. And we're going to explain why it's not a square. So this is still a proof, but we're explaining why it's not a square now. So we're going to have to figure out the difference between a rhombus and a square. For a rhombus is really similar to a square, except a square is going to have right angles, okay? So if you look at our picture right here, angle L, that's not a right angle. That doesn't look like a right angle, okay? It's definitely obtuse. And then angle P is acute. So we know those aren't going to be right angles, but we have to prove it. So what we're going to do is we're going to do this. If we prove that 2 sides that touch are not perpendicular, then it can't be a square because squares need to have right angles in the corners. So first you're going to do the slope, and we're going to pick 2 sides, do the slopes of them, and make sure that they're not negative reciprocals. Okay, so if you can do whatever ones you want, but if you want to do the same ones I do, I'm going to do angle L. So I'm going to do these 2 sides. So find the slope of those 2 sides, and then unpause the video once you're done. Okay, so when you do that, you're going to get 4 and 1/4. And those are reciprocals, but they're not negative reciprocals. So that means it is not a square. Okay, if you had 4/1 and negative 4/1, then it would be negative reciprocals, and then it would be a square. But since they're both positive, then it cannot be a right angle. Okay, and then this is the last piece. So for this one, we're going to first prove that the triangle is an isosceles right triangle. Now, you guys should be pretty good at this by now because we've done this about 4 times. So we're going to first prove that it's a right triangle. If something's a right triangle, it needs a 90-degree angle. So you're going to have to find perpendicular lines. So I'm going to leave this one to you guys. Try it on your own, see if you can get the right angle. And then you're going to see if you can find out that it's isosceles, which means you need 2 sides the same. Okay, so this is our answer for the first part, which is proving that we have a right angle. So OR and OP the slopes are going to be negative reciprocals, which means they are perpendicular. So angle O is a right angle, which means triangle ROP is going to be a right triangle. The isosceles part means that 2 sides need to be the same. So you're going to do the distance to find those lengths. And after using the distance formula, you can see that they're the same. So that means 2 of the sides are congruent, which makes it isosceles. And to explain that, we're going to write the same thing we've been writing. So 2 of the sides have negative reciprocal slopes. So we've got a right angle, which means it's a right triangle. And then 2 sides are congruent. So that means the triangle is an isosceles triangle. Okay, so to finish this lesson out, we're going to find the coordinates of point E, which is going to be added onto this picture here, so that we have a square. So what we're going to do, what we're actually doing with this, if you have a hard time trying to figure out the missing piece, is we're going to take this segment here, and we're going to just copy it down there. Okay, so that segment is going up 2 over 4. So we're going to go right here and we're going to go up 2 over 4. And wherever we land, okay, that is going to end up being a point where this segment will be parallel and congruent to this one. And we know that in a square, the opposite sides are going to be parallel and congruent. So that's what you're going to do. And we're going to end up getting point E in that spot right there, which is the point -2, -4. And we're going to prove that it's a square. And there's a couple different ways you can prove that it's a square. But if we look at these rules, because we didn't look at this for a square yet, there's a couple different ways. You can say that it's a quadrilateral that has 4 congruent sides and 4 right angles, which is a lot of work. You would have to do the slope formula 4 times and the distance formula 4 times. Or you can say that 2 consecutive sides of a rectangle are congruent. So you'd have to do a rectangle proof first, and then do the 2 consecutive sides. The third one says that if you have a rhombus that contains a right angle, then it's a square. Again, you'd have to prove that it's a rhombus first to do that. Or the last one is that you have a quadrilateral that has both rectangle and rhombus properties. All of those properties. Which there's a couple different ways you can figure that out. But what we're going to use is we're going to use the most important pieces from both and combine them together. So if the diagonals of a rectangle, those will always be congruent. And the diagonals of a rhombus will always be perpendicular. And that will always be true for both of those. And if you combine those, it becomes a square. So these 2 diagonals here are congruent and they're perpendicular, and there's no other shape that has that. So if we can do both of those things and prove those, then that is enough to say that we have a square. So let's go here and let's find the slopes of both diagonals and the lengths of both diagonals. So we're using the distance formula twice and the slope formula twice. Okay, so the slope formula is this for both of those, and we see that they are negative reciprocals, which means they are perpendicular. And then the distance formula for both end up being the same number, so that means they are congruent. And that means this final statement is true. The diagonals of a square are both congruent and perpendicular, which means that we can, and that's only true for a square, so that means that we've proven it. Okay? We've proven that the diagonals are perpendicular right here, and that they are congruent right here. So that means that ROPE is a square because, and then you would say this stuff, because the diagonals are both perpendicular and congruent. Okay, so as long as you've got the work to show it and the sentence to back it up, then you've done everything that you need to do. And then the homework for this is going to be pretty similar to, number 2. Number 2 from this lesson is going to be pretty close to what the homework is. So if you are having any trouble with the homework, look back to example 2 and do pretty much the same thing we did there. Okay? If you have any questions on anything, make sure you let me know. And you're going to have that homework for this lesson be due on Friday.